whenever I come across a trig identity, I have a strong urge to try and simplify it. But with this specific question, that is a terrible idea. So the question is, for which values of x in the interval from 0, inclusive of 0, to 360 degrees, not inclusive of 360 degrees, is the identity undefined? So the reason why it's not a good idea to simplify this identity is because if we're looking for values of x for which this is undefined, then by simplifying it, we might be getting rid of these values. So for example, x squared over x is also equal to x. Now, x squared over x is undefined at x equal to 0 because the denominator cannot equal to 0. However, x is defined for all real numbers, so in other words, it's not undefined anywhere. And although these two are equal, this is undefined at x equal to 0, whereas x isn't. So I hope it's quite clear now why you shouldn't simplify it, and instead just look for where the denominator can equal to 0, where any denominator can equal to 0. So first off, we have this denominator. So 1 minus cos of x equal to 0 is something that could yield us with an undefined value for x, as well as 1 plus cos of x equal to 0. And then also this, tan of x times by sine of 2x equals 0. And now there's a hidden trick in this question which makes it very interesting. You may think you've dealt with all of these denominators, but in fact there is one other denominator which is hidden, and comment down below if you know where it's hidden. But it's hidden, I'll tell you now, it's hidden in this tan of x, because tan of x, we know, is equal to sine of x over cos of x. So if cos of x is equal to 0, then tan of x is undefined. So we can write another comma, or where cos of x is equal to 0. And I'll keep that aside over here for now. So let's deal with this first. If we take this cos of x across, we have cos of x equal to 1. So it'll be undefined where cos of x is equal to 1. And in this interval, from 0 to 360 degrees, cos of x looks like this, where this is 360, that's 180, this is obviously 0. So cos of x equal to 1 is going to be at 0 and at 360 degrees, but we're not including 360 degrees, so just equal to 0. So let me go ahead and clear that up. So we can write x equal to 0. So that's important. This is an important value for us. Alright, now let's deal with this one. Cos of x equal to negative 1. So cos of x is equal to negative 1 at 180 degrees over here. So x equals to 180 degrees. And now let's deal with this. Tan of x times by sine of 2x equal to 0. So these are both, funny enough, identities that can be expanded. And now tan of x is equal to sine of x over cos of x, and sine of 2x is equal to 2 sine of x cos of x, and then the same thing is equal to 0. So this cos of x and this cos of x can be cancelled out, and then we have 2 sine squared of x equal to 0. And now where sine of x is equal to 0, cos of x will also be equal to 0, and our sine of x graph looks something like this. Essentially, we only need to look for where sine of x equals to 0, because we're squaring it, so it makes sense. And sine of x looks like that. So this is equal to 0 at x equal to 0 and at x equal to 180 degrees. Now we have this last one to deal with. Let's put it over here, where cos of x is equal to 0, and remember this is our cos graph here, and our cos graph intersects the x-axis at these two values, which is 90 degrees and 270 degrees. So we have x equal to 90 degrees and x equal to 270 degrees. So there you go, we've found all these values, and now we simply need to write it in the form of an answer. So we have x is an element of the set containing 0 degrees 90 degrees, 180 degrees, and 270 degrees. And that's the final answer. So I hope you found this video helpful or interesting. And if you wouldn't mind, please leave this video a like if you did enjoy it, and consider subscribing. Thank you very much.